Hi, this is Vigyan Singhal from Oski Technology, and today I'm going to talk about the important problem of determining when you're done with your formal test bench. It's an important problem because if you've decided to replace simulation on the block you're verifying with formal verification, you want to know when to sign off with the work you've done. There are three things you have to cover to decide that you're finished with the formal test bench and you're ready to sign off. Number one is constraints. Constraints are built in your formal test bench to ensure that the inputs that coming in from all sides of designs are legal, and the design is not exercising illegal behavior that you do not care about. But it's easy to write constraints and make mistakes so that you can accidentally over constrain the design. Sometimes you also intentionally over constrain the design to disallow certain use behavior, certain use cases that are not supported in the design, or if there are known bugs that you want to work around the bugs, or if some part of the functionality is tested through some other means like simulation, you want to disallow that. But the problem I want to focus on is unintentional over constraints, and you want to make sure that the unintentional over constraints you have don't exist. There are ways in which you can find the unintentional over constraints, and three possible solutions for those are cross proofs, which is taking your constraints and proving them on the neighboring blocks with formal verification. A second possibility to deal with over constraints is instantiating over constraints in simulation, and the third is using coverage with the formal tools. And we're going to cover all of these in a different video, so I'm going to leave it at that right now. So let's come to the second area that you want to focus on to decide whether you're ready to sign off with formal verification or not, and that is checkers, your list of checkers. Even in simulation, you have to watch out for your list of checkers. Say you have 100% coverage in your design, even then if you haven't written the checkers you're supposed to check, simulation is useless. And the same applies for formal verification. If you haven't exhaustively covered all the functionality that you want to check on your design, then your formal verification is not ready to, you're not ready to sign off with formal. You can verify very local things in your design, local RTL assertions, FSM pragmas, state machine encoding, and so on. And that's good and can find some bugs. Or you can be more exhaustive and try to verify interfaces. For example, if I have a design which goes from AXI4 interface on my left side to DDR2 interface on the right side, a memory controller, then you can verify compliance with AXI4 interface on the left side, DDR2 protocol properties on the right side, and you can find some more bugs and be more exhaustive. Yet you haven't done exhaustive verification on this block, and you haven't verified the entire end-to-end functionality. So if you want to be fully exhaustive with the block, you want to make sure that your list of checkers contains all the end-to-end checkers you want on the design, going from the inputs of the design to the outputs of the design, and having reference models to cover all of that. So that's number two, checkers. And then the third important thing to cover is complexity. Complexity is important for formal verification because the search space is huge. You're dealing with a large number of states. As you go from the research states farther and farther, the proofs become harder and harder, and especially if you're doing end-to-end verification, you will almost always get bounded proofs. So the thing about bounded proofs is that the proofs are only good up to the bound you have, and the analysis you have to do is to determine whether the bound you got with the formal tools was good enough for the design you have, for the checkers you wrote, and for the abstraction models you used. And that's very important because if the bounds is not good enough, you could miss a bug which is farther than the bounds you got. So again, coming back, there were three things you want to look at: your constraints, your checkers, and your proof bounds, which is complexity. Thank you.